This is a practice exercise from page 127 in the textbook. We're going to rank the conductivity of various solutions. They give us a hint that in order to rank the conductivity, we want to think about the number of ions present in the solution. When we think about the number of ions present in a solution, what we're really thinking about is the type of electrolyte we have. So electrolytes are the things they put in sports drinks, which is really just salt, sodium chloride. That means that when you put it into water, it dissociates or breaks apart into ions. Those ions can then help conduct electricity. Electricity conduction is what makes it an electrolyte. So we're going to take a look at these four compounds, decide what type of electrolyte we have. If we have an electrolyte, figure out how many ions it would break apart into, and that'll help us rank them based on their conductivity. So starting with the first compound, we've got a calcium nitrate. So you should recognize this as an ionic compound. Since it's ionic, that means it's going to be a strong electrolyte. And that means that when we put it into solution, it's going to completely break apart. The reason I know it's going to completely break apart is that it contains the nitrate anion, and based on my solubility rules, anything that contains nitrate must be soluble. So when I put this into solution, it's going to break apart into one calcium ion, and it's going to break apart into two nitrate ions. And I can tell that it's going to break apart into two nitrate ions because the formula is CaNO3 which means I'm going to get a total of 3 ions when this compound is dissolved in water. Let's take a look at the next one. I've got glucose, C6H12O6. This is a molecular compound. I can tell because it's only composed of nonmetals as opposed to the calcium nitrate, which had a metal and a nonmetal. Molecular compounds tend to be non-electrolytes. The only exception to that is acids, and we'll take a look at that in a second here. But non-acidic molecular compounds tend to be non-electrolytes, and since this is sugar, this is definitely a non-electrolyte. So since this is a non-electrolyte, it will not break apart into ions. Since it won't break apart into ions, we don't need to worry about counting any of them. The next one we have is sodium acetate. Now again, we should recognize this as an ionic compound. I can tell it's ionic because it's got a metal in it. Since it's ionic, it's probably a strong electrolyte. We should double check the solubility. Since we know that we've got the acetate ion, you can look that up in your solubility rules, and the acetate ion is always soluble. So since this is a soluble ionic compound, it is a strong electrolyte. Which means we now need to think about how many ions it breaks apart into. So we can see that this should break apart into the Na+ ion, and it should break apart into the acetate anion. So one cation, one anion means that I've got 2 total ions. The last substance I have is acetic acid. Now, this is a molecular compound, but they're telling us that's an acid, and this is very important. Even though it doesn't have any metals in it, it behaves similarly to ionic compounds, and that when you put it into solution, it will partially dissociate. This is not one of the 7 strong acids listed in your textbook, so this is a weak acid. And since it's a weak acid, that means that it is also a weak electrolyte. The only way I can tell that this is a weak acid is that it's not one of the 7 strong acids listed. So what happens when you put a weak acid into solution or a weak electrolyte? That means that it will mostly stick together. It will only partially dissociate. So this partially dissociates or partially ionizes. and it's very low. Only about 1% of it breaks apart, 99% of it sticks together. So what that means is that in solution, I actually have mostly molecules I have very, very few ions. Now the numbers that they gave us at the beginning here when they told us that we had 0.1 mole dissolved in 1 liter of water, essentially what that means is that we've got equal amounts of all of them, equal concentrations, so we don't need to worry about differences in concentrations. All we need to think about are the number of ions present when we rank them. So in order to get this ranking set up, we're going to go in order of increasing conductivity. So we're going to put the least conductive on this end. Most conductive over here. And again, in order to conduct electricity, we need to have ions in the solution. So the least conductive substance is going to be the one that forms the least or no ions in solution. So that is going to be our molecular compound, our sugar. Okay. Then becoming a little bit more conductive is our weak acid, our weak electrolyte. It is still mostly molecules, but since it partially dissociates, there's going to be a little bit of conductivity. It's going to be very weak, but partially dissociated. Then moving on, the next two things I have were my ionic compounds. So they're both strong electrolytes. They're both very good at conducting electricity, but I've got something that breaks apart into 3 ions, my calcium nitrate, versus something that breaks apart into only 2 ions, my sodium acetate. Since the sodium acetate only breaks into 2 ions, it's going to conduct slightly less electricity than my calcium nitrate, which is breaking apart into 3 ions. So again, in order to determine the conductivity of a substance, you need to figure out what kind of electrolyte you have. Your options are a strong electrolyte. Those are typically ionic compounds that completely dissociate. Strong acids would also be strong electrolytes. You could have a weak electrolyte, which only partially dissociates, and that's typically going to happen when you have a weak acid, which is going to look like a molecular compound, but you should be able to identify it as an acid. The last type of electrolyte we have are the non-electrolytes, and non-electrolytes are covalent or molecular compounds that are not acids. So sugar, in this case, was a non-electrolyte. And then in terms of conductivity, the strong electrolytes are going to be able to conduct electricity. The more ions it breaks apart into, the more conductive it is. The weak electrolytes will weakly be able to conduct electricity, and non-electrolytes do not conduct electricity.